Hi, welcome to Mathematics Made Easy by Mary MJ. Here I am discussing CBSE Class 10 Chapter 1 Real Numbers. This is my second part of this video. Here we will discuss Fundamental Theorem of Arithmetic. In the last video we were discussing about Euclidean division lemma. So here it is Fundamental Theorem of Arithmetic. That means every composite number can be expressed as a product of primes. So composite number means there will be factors for that, and we have to write every composite number as a product of primes. Any composite number can be expressed as product of prime numbers. We'll take one example for that. We'll take 140. How to write 140 as a product of prime? So 140 we have to factorize it. 2 with 2 will do. So 70, again 2, 35. So again factorizing with 5, we'll get it as 7, and with 7 it is 1. So 140 can be written as 2 into 2 into 5 into 7. So we can see these all are primes. 2, 2, 5 and 7 are primes. If I am writing it as 2 into 2 into 5 into 7, or if I am writing it as 2 into 5 into 7 into 2, there is no change in the value. That means any number, any composite number can be written in terms of prime numbers. There is no order in which the prime numbers occur, prime factors occur. There is no order. If I am changing the order and writing also, there is no change in the answer. That is 5 into 7 into 2 into 2 also. It is correct answer, that is 140 itself. So, according to theorem of arithmetic, fundamental theorem of arithmetic, every composite number can be expressed as product of primes. Very important result. Then, and one more question we will try it using this. Let it be 3825. So, we will factorize 3825 with 5. 5 sevens are 35. Then remaining 3 in 32, 5 6 are 30, then 25 5. Again with 5 ones are 5, 25 means 5 5s, again 15 3. Again it won't go in 5, we can factorize using 3 5s are 15, 3 ones are. Again with 3 ones are 3, then 21 means 3 sevens. So 17 is a prime factor, so we have to stop it there. We cannot factorize it again, so that I can write 3825 as 5 into 5 into 3 into 3 into 17, or that is equal to 5 square into 3 square into 17. There is no matter in which the order is coming. So in any order we can write the factors. Then also we are writing as the product of primes. Any composite number can be written as product of primes. Then the second concept we have to study here is HCF of two numbers A and B into LCM of two numbers A and B is the same as the product of two numbers. So again another important concept, HCF of two numbers A and B and LCM of two numbers A and B gives the product of two numbers A and B. So using this we will do the next question. Next question is, find the LCM and HCF. Find the LCM and HCF of 6 and 20 by prime factorization method. By prime factorization method. So how to find out the LCM and HCF? So first we have to find out what is the prime factors of 6. That is, any composite number can be written as the product of primes. So 6 can be written as 2 into 3 and 20 can be written as 2 into 2 into 5. So from here we know how to find out the LCM and HCF. HCF is the common factor in both. Common in both is only 1, 2 is common in both. So HCF of 6 and 20 is 2. Now we need to find out what is the LCM. LCM is 10 into 3, that is 30, 30 into 2, that is 60. All of you know how to find out the LCM because you have studied in your lower classes. No need of further explanation for that. So we can see here HCF is 2, LCM is 60. Now what is the HCF and LCM of both the numbers? What we will get if you are multiplying these two, HCF into LCM. HCF is 2 and LCM is 60. We are getting it as 120. And what about the product of two numbers? Product of two numbers. Product of two numbers is equal to 2 into 60. Again, it is 120. So we can say that HCF into LCM is equal to product of two numbers. So that is the concept which we were learning just now. Now another question, find the HCF of 96 and 404 by prime factorization method. By prime factorization method. Okay, we have to find out what is 96 and 404. So first we will factorize and find out 96 factors. 96, if I am factorizing, we'll start with 2. So 2 here 4 times, then 8, 48. Again, if I am factorizing by 2, we'll get it as 24. Again with 2, we will get it as 12. Then again with 2, 6. Then 2, we'll get it as 3. So 3, 1. So what is 96? 96 can be written as, how many 2's it is there? 1, 2, 3, 4, 5 2's. That is 2 raised to 5 into 3. And how can we write 404? 404 is equal to, we have to find out by prime factorization itself. So 404, I am dividing, I am factorizing. So 2 here 2 times, 0, 2. Again factorizing, you are getting it as 101. Then, so in 101, 2 will not, we cannot divide using 101. 101 is a prime number. So we have to stop it there and we can write this as 2 square into 101. So 404 can be written as 2 square into 101. Now we have to find out the HCF of these two numbers. Find the HCF of 96 and 404 by prime factorization method. So how to find out the HCF of both these numbers? We can see here the common in both 96 and 404. Here 2 square is there, here 2 raised to 5 is there. Remaining 3 and 101, there is nothing in common. So we have to find out only what is common in 2 square and 2 raised to 5. The common term in 2 square and 2 raised to 5 will be 2 square. So we can say that HCF of 96 and 404 is equal to 2 square. Now, we have to find out what is, after finding out the HCM, we are supposed to find out what is the LCM. Again, same question it is asked, find LCM. So here we know the two numbers are 96 and 404 and also we have found what is the HCF. Now we need to find out LCM. So we know that HCF of two numbers into LCM of two numbers gives A into B or the product of two numbers. Now I need to find out what is the LCM. That means A into B divided by HCF of the two numbers. So A into B means A and B are the two numbers, that is 96 into 404. Divided by HCF, already we have got the HCF as 2 square, that is 4. We can cancel out the common terms. Common terms 4 here 2 times, so we'll get it as 8, remaining 16, 4 4s are 16. So 24 into 404. Multiplying this, we'll get it as 9696. So the LCM is 9696. So what you are doing here is we are applying in the formula HCF into LCM is equal to A into B. So first finding HCF, then we are using that in this formula, in this concept, and finding out what is the LCM. Now next question, that is from the exercise questions. Given that HCF of 306, 657 is equal to 9. We should find what is the LCM of these two numbers. We have to find out what is the LCM of 306 and 657. So as usual, we know that HCF into LCM gives the product of the two numbers. And here HCF is given as 9, but LCM we are supposed to find out. Product of two numbers is 306 and 657. We can find out what is the LCM. That is 306 into 657 divided by 9. So we can cancel this 9 over here. 9 3s are 27, remaining 36. 36, 9 4 times in 36. So multiplying this, we will get the answer. So we have to find out what is the answer for this. That is multiply 657 into 34. So 7 4s are 28, 2, 20, 22, 24, 26. Then again 1, 15, 17, 18, 19. Yeah. So the answer will be 8, 3, 3, 2, 2. So LCM is equal to 22,338. So similarly, one more question is there. That is, the question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. How can we say that these two are composite numbers? We will take the first question first. That is 7 into 11 into 13 plus 13. In these two terms, this is the first term, this is the second term. In these two terms, we can see that 13 is common for both. So 13 we can keep it outside. Remaining 7 into 11 plus 1. That is 13 into 7 into 11 gives 77 plus 1. That is 13 into 78. So we can write this term, that is 7 into 11 into 13 plus 13, can be written as the product of two numbers. That means if we are writing in terms of if we are writing as a product of two numbers, we can say that those are composite numbers. So this is composite. This is composite. Now the second one. Second one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here also we can see that 5 is common in the first term and second term. Considering this is one term, because it is product of so many numbers that comes as a single term. So from this take 5 outside. Remaining numbers we have to multiply it and write it together. 7 into 6 into 4 into 3 into 2 into 1. So we'll get it as 1008 plus 1. So that is equal to, that is here if I am taking 5 outside, here remains 1 because 5 means it is 5 into 1 actually. So from these two you are taking 5 outside, remaining here this multiplying we are getting it at 1008 plus 1, that is 5 into 1009. There also we can see that we are able to write this complete term as a product of two numbers, therefore this also it is composite. Composite means we are having factors. That number which is having factors we call it as composite number. So in this video we were discussing about fundamental theorem of arithmetic and also prime factorization, how to find out HCF LCM and what is the relation connecting HCF LCM and product of two numbers. So in the next video we'll finish off the remaining chapter along with some problems also. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe. Also click on the bell icon for more updates and notifications. Bye.